Hello, here with us are Elmar, Head of Product Management, and Philip, Application Engineer for IRS sources. They are explaining to us what is an infrared source. Elmar, what's an optical gas sensor and which important components does it need?
Optical gas sensors measures a wide range of gases from the medical, safety and industry, environment and automotive segment. They are typically based on absorption or photoacoustic spectroscopy and refers to spectroscopic techniques that measures the absorption of radiation as a function of wavelengths due to its interaction with the sample. An IR source is used for IR spectroscopy, which couples the emission energy into the cuvette with the gas sample. Depending on the intensity of the source, the gas concentration, the composition, the path length or the volume, parts of this energy is absorbed by the IR active molecules. The IR detector or the piezo microphone measures the intensity, which determines the gas concentration by means of the gas signal evaluation.
Elmar, which components does Axetris offer?
Axetris offers the key component IR source, the EMIRS 200 and EMIRS 50, required for the implementation of non-dispersive infrared spectroscopy and photoacoustic spectroscopy for gas concentration measurement and attenuated total reflectance or absorption spectroscopy for liquid analysis. The scalable product range offers for all sensor designs and techniques an optimal solution. The system can be adapted to the individual optical design requirement. The modular product range is based on the chip generation and type, the packaging like SND or TO, the body, for example reflector type, broadband and passband filters, and at the end sealing option and customization or the customized solutions.
Philip, what does EMIRS stand for and what does MEMS-based processes mean?
The product label EMIRS stands for Electrically Modulated Infrared Source and summarizes the most relevant key elements. In general, MEMS enables the production of sensors and actuators whose functional layers are in the order of a few micrometers or even smaller. So most of the magic of the EMIRS happens at a level of scale which is not visible for the eye. To fabricate such devices, we have our own cleanroom facilities here in Switzerland. These rooms need to be very low of level of dust in the air, which is necessary to perform these high complex MEMS processes, like lithography steps and deposition or etching of our functional layers.
Can you explain to us what are the advantages of a MEMS-based thermal infrared source?
The technology MEMS enables the fabrication of smaller, faster and more reliable infrared sources. Like a bulb, these sources run by electric power. But because of their size and thereby much smaller thermal mass, they can be modulated by a frequency of up to 100 Hz. The main asset of our EMIRS is the so-called black platinum layer. This layer looks on the microscale like a forest of 1,000 and 1,000 of tiny trees and has an emission coefficient in the near and mid-infrared spectra like a black body. This technology is scalable and at the same time stable in production, which is key for a step into high volume markets.
And our last question to Elmar, what are the typical applications and markets where IR sources are needed?
Typical applications for our EMIRS 200 are anesthesia monitoring, where a range of gases in the mid-infrared range need to be measured. The same applies for refrigerant monitoring. These are gases that are harmful for the atmosphere. Those gases need to be monitored for large installations. Semiconductor, the industry uses specific gases for processes. They also need to be monitored and analyzed. Or exhaust gas analysis in the automotive industry, where an analysis is required. Typical target applications for the EMIRS 50 are HVAC and indoor quality monitoring in the environmental sector, portable devices for combustible and toxic gas detection in the industrial and safety segment, air quality monitoring in large cities, and breath analysis, for example, capnography.
Thank you.